Hello everyone, welcome back. I am Mr. Cobalt, and today we are going to finally talk about the atomic theory by John Dalton. So John Dalton, as we saw, he was the guy who formulated the law of multiple proportions. And so John Dalton put forth his four postulates of his atomic theory. Now, John Dalton is not the first one to put forth this idea that everything is made up of atoms. This actually goes way back to the Greek philosophers, in particular Democritus. Democritus was the first Greek philosopher to put forth this idea that everything is made of atoms. And the word atom actually comes from the Greek word atomos, which means undivided or not divisible. So that is where we get the word atom from. So Dalton is not the first one to use the word. But John Dalton is considered the father of modern atomic theory because he's the one who gave it life. And here are his four postulates. We went over the three laws that gave support to these postulates. We went over the law of the conservation of mass, which says that mass is not created nor destroyed. The law of definite proportions means that the elements, the ratio of the masses of the elements that make up a compound is always the same. It stays the same no matter where it came from, no matter where you got the substance, no matter how you made the substance. The ratio of the constituent elements is going to be the same by mass. And then the law of multiple proportions was that if you have two compounds made up of the same two elements, then one compound, the masses of one element in that compound, when you compare to 1 gram of the other element in the compounds, the ratio of those masses are going to be a small whole number ratio. And so John Dalton came up with these four postulates in his atomic theory that is consistent with all those laws. So the first postulate is that each element is composed of tiny, indestructible particles called atoms. Again, atom comes from the Greek word meaning indestructible, not divisible. So in Dalton's mind, these were like cannonballs. So if you think of a large cannonball, that was his idea of an atom, just one solid sphere, not made of parts, not made of particles, just an indestructible sphere. So we know that this is not true today because we know today that the atom is actually made up of even smaller particles. We call them subatomic particles. And we'll get to that in a later video. So what I'm referring to are the protons, electrons, and neutrons. These are particles that Dalton had no idea about. So this is one of his postulates. So it's indestructible. So this is not true today. Number two, all atoms of a given element have the same mass and other properties that distinguish them from the atoms of other elements. So again, this is kind of based on the laws, or at least consistent with the laws. So all atoms have the same mass. That would be expected, given the fact that you have conservation of mass, the definite proportions. So you always get the same ratio of elements in a given compound. So it makes sense that they would have all the same mass, and especially the other properties that they have. So elements have different properties that distinguish them. That's still true today. But what is not true today is that all atoms of the same element have the same mass. Again, we know about isotopes today. Isotopes or something I'm going to get into a later video, but isotopes are atoms of the same element that differ in mass because they have different neutrons. And again, Dalton didn't know anything about neutrons, so it's understandable that he would not know anything about isotopes. So this is not quite true today. So they do have different atoms of the same element can have different masses, but that's not going to affect their behavior. That's not going to affect, for the most part, their other characteristics that make the elements the same elements have the same characteristics, and those characteristics will distinguish them from other elements. Number 3, atoms combine in simple whole number ratios to form compounds. Again, that falls out of or is consistent with the law of definite proportions, as we saw before. Again, law of definite proportions says that the mass ratio of the elements that make up a compound is going to be a whole number ratio. And so this idea that the compound is made up of whole number ratio of atoms, and those atoms have the same masses regardless of where where you get this substance from or where you get this compound from, it's going to have the same ratio. So that is consistent with the law of definite proportions. And 4, atoms of one element cannot change into atoms of another element. In a chemical reaction, atoms only change the way they're bound to each other, so they're rearranged. So again, this is consistent with the law of the conservation of mass. You're not going to change one element into another. That would be like destroying one element and then creating the new element out of it. And so that would go against the theory. This idea that they're indestructible. And it would also go against this, the law of conservation of mass, which says matter is not created nor destroyed. But they are rearranged. And so that makes sense. If you're going to do a chemical reaction, then you would expect that you get this rearrangement of atoms rather than a destruction. And that fits with the law of conservation of mass, right? So if you're not losing any atoms and you're not creating any atoms, then the mass should stay the same because the number of atoms are going to stay the same. The only difference is going to be how they are bound to each other, the rearrangement of the atoms. So that is a look at John Dalton's 4 postulates of his atomic theory, and this is what we started with, but this is not how the atomic theory is today. It has developed, and today we hold to a much different theory. Well, I would say different theory, but it's a developed atomic theory compared to what John Dalton was envisioning. I hope this is helpful. If you enjoyed this, then please share this video with other people. Make a comment in the comment section if you want to hear anything or if you want me to go over anything in a later video. So subscribe to the channel, ring the bell for notifications, and thank you for joining me, and I'll see you guys next time.